So here's my wall leaning at 70 degrees to the horizontal. 5 meters from the base of that wall, there is a support that is put up to hold the wall from falling over. And that support is attached to the wall. So here it's attached to the wall. 2.5 meters here is the base. So this length is 2.5 meters. We've just drawn a triangle. Determine the length of the support. I'll call that x. And we also need to determine the angle between the wall and the support. I'll call that theta. So now that we've drawn our diagram, now the question becomes easier. So when we look at it, can we use our sine law? Do we have an angle and an opposite side? No. We have an angle, but we don't know its opposite side. So then we're going to use our cosine law if we're trying to find x. Okay? X squared will go on that side. We'll have 2.5 squared plus 5 squared minus 2 times 2.5 times 5 cos of 70 degrees. And we can type that all in all at once. 2.5 squared plus 5 squared minus 2 times 2.5 times 5 cos 70, 22.69. And then to find x, just need to square root that answer, 4.8, which is the nearest tenth of a meter, 4.8 meters. Now that you have 4.8 meters, if you were solving for angle theta, you now have options. Okay? So I'm going to write in 4.8 here for that x. I'm going to circle that because that's new information. Because what I want to look at is, could I solve for theta if I didn't have the 4.8? Can I use only the information that I have to solve for theta? So sine law, you need a side and an opposite. So that would work, but I don't know the angle and opposite side given unless I use the 4.8. So if I want to find theta, I could use the sine law now, but I'd have to use the 4.8. Okay? There's no way to find that angle theta unless we use the 4.8. If we use the 4.8, we have options. You can use the sine law, because if I use the 4.8, do I have an angle and an opposite side? Yes. Or I could use the cosine law, because do I have all three sides? Yes. Personally, I like the sine law better than the cosine law. It's shorter, so I would probably start with the sine law. So as soon as I have an angle and an opposite side, I can solve for theta. Sine of theta over 5 equals sine of 70 over 4.8. And if I multiply both sides by 5, get sine of theta is 5 sine 70 over 4.8. Now I'm writing 4.8, but that number was rounded. Whenever I do my calculations, I'm going to use all of these decimal places. 4.764399. So when I go to my calculations and type this in, 5 sine 70 divide by 4.764. I'm just going to go second answer so that I use my answer that I had there before, and that keeps all of those decimal places. And I get 0.9861. Well, we write that in to figure out where we are in our equation. 0.9861. Well, we still need to find theta. How do I do that? Sine inverse of that answer, 80.5. Did it ask for the nearest degree? Or did it say to the nearest tenth of a degree? Nearest degree? So I should go back 80.45. The nearest degree would just be 80. So 80 degrees is the nearest degree. Now, sine is positive. It could have an answer in quadrant 1 or quadrant 2. But for our example, does the quadrant 2 answer make sense? So, could we have a bigger angle there? Probably not. 80 degrees is the only one. That should work. Yes. You're getting 78. Did you use all your decimal places or did you use 4.8? Yeah, so you rounded early. And by using a rounded value early, your final answer is off. So that's why I said we'll use all the decimal places that we have so that our answer stays as accurate as possible. Question number 6.